Well, hello again, everybody. I've got no idea if this will work, but I thought we would try another impromptu live stream. Now, these don't normally go very well because, as you know, my internet connection really is very poor here. So it really doesn't usually work at all, and we constantly get booted out. Well, if that happens, we'll probably cancel the stream because that's no fun for anyone. But if anybody is managing to watch, I'll just tell you what we've got on the bench today. We've actually got a pair of Solartron voltmeters, digital voltmeters. Now, back in the day, these would have been, I suspect, really very expensive and considered quite exotic because these are 7.5-digit meters. But unfortunately, the two that I purchased, they both have arrived unserviceable. And I think they were no good. I actually knew that when I was purchasing them that they weren't going to work. But unfortunately, as well as not working, they appear to have been really badly trashed in delivery. Now, I don't blame the seller. I think he'd actually done his best to wrap these things up. But unfortunately, they'd obviously been dropped and kicked around the depot. Most of the front panels were smashed on them. They've got clips, handles on the front. They were smashed off. So, yeah, they arrived in a little bit of a mess. The cases were dented. As I say, I don't blame the seller. I think they just had a really poor ride. I can just see some comments there. So, obviously, something's working. So, I assume Andrew and Paul are watching. So, I assume you can leave a comment if you can actually hear me, if it's actually working. We never know with these things, do we? It's always a little bit desperate. So I actually believe that the life of these meters, I think they're starting to manufacture them. I think the first ones were made around 19, I think it might have been 71 or 72, but they actually did carry on manufacturing these, I think, into the early 80s. Now, I was just looking for some date codes on these, but one of the problems I have got is these boards are absolutely filthy. I've got two of these units. As I say, my idea was perhaps we could make one good voltmeter out of two unserviceable ones. I don't know if that's going to be the case, but they looked as though things have been tipped inside them. They are very, very dirty. They're in a real mess. Now, this one is just kind of covered in a thick layer of dust. Oh, I've just found a metal washer. I'm sure that wouldn't do any good. They were covered in a thick layer of dust, but the other unit that I've got on my floor down here, this looks as though something's been tipped into it, and I suspect probably in the past some engineer probably had his cup of tea, knocked it over, and it ran into the circuit boards because they are absolutely thick and sticky with something. So that they could do with cleaning up. Whereas this one, just looking inside it, I can see that a lot of the legs on the ICs, they do appear to be really rusty. There's a lot of dust in here, but things look as though they are very rusty. There's a relay at the back of the unit here. Unfortunately, we're a bit limited with the cameras, aren't we? So you can't see much. I can see that this relay on it, it's got a metal can on it, and again, it's just thick with rust. As are any other fixings which are made from steel. Looks like a lot of these things are actually manufactured from aluminium and stainless steel, but anything which is just steel, I can clearly see like there is some steel screws as well. I can see they've just got quite a thick layer of surface rust on them. So again, unfortunately, I think these units have probably suffered some quite hard lives in the past, and they're in a little bit of a bad way. So I think the first thing we're actually going to do is power them up. Now, these units have actually been powered up very briefly by me, but certainly we haven't done any exhaustive testing. So I think what we'll do is we'll power them up, and well, we'll see if we let the smoke out. I've done a visual inspection. It doesn't look as though anything's been burnt or on fire. There's no obvious bulging capacitors in the power supply. Interestingly enough, I haven't looked at the circuit diagrams yet, but it looks as though we have some form of high frequency switching power supply with multiple outputs, but I've yet to look at the circuit diagrams for this or to dig into it. But I do believe that the power supply will come up. So I think what I am going to do is I'm going to power this up, and we'll just do the basic things that we like to do, which is start off by checking the power supply rails. Because if you haven't got power supply rails, there really isn't any purpose in going any further forward with that. I've also, for anybody playing along at home, you'll see that I've put a Dropbox link, which hopefully won't be full of viruses, but there is a Dropbox link there. So there is the full operating manual in there. And I've also provided a lot of close-up pictures because I realise my video camera isn't particularly good. So if you want to look at some close-up pictures of the boards, there's some pictures there. If you look at that Dropbox link, you'll see pictures of the internals of these, some close-up pictures. And you can also download a full PDF of the manual. It is quite a large manual. I think it's about 16 megabytes, something like that. But if anybody's got that to hand, I'm sure that will be useful because you'll be able to answer some questions as we go. So without any further ado, I'm just going to plug in. I'm not going to bother using a lamp limiter or things like that because in my experience, switch mode power supplies don't like them, and they can actually cause damage in some instances. So it's 50-50 whether they cause damage or not. So let's plug in, see what happens. Okay, well, I can see some little bits of no, something's happening. Can you hear that? The unit's actually clicking. Don't have anything on the display at the moment. You can definitely hear some relays clicking though. Right, okay, let's have a look at them power supply rails, see what we've got. Can you see that there? Yeah, I think you can. Oh, we've got a few people in. Let me just say hello to everybody. So we've got Andrew in the house. Hello, Andrew. Got Cody's. Hello, Paul. Who else have we got? Oh, we've got Michael. Hello, Michael. Oh, and Graham's popped in as well. Hello, Graham. And Brett. Oh, pretty much a full house. And even Benji's here. So all the important people are here. Oh, and Marco's popped in as well. What's Marco saying? Firmware on floppy disk. No floppy disks in this one. Oh, looks like we've actually got some. While I was talking, it looks as though we've the displays come up. So maybe some electrolytic capacitors have started to reform there or something. Not sure. Anyway, I want to check these supply rails. In fact, what I am going to do is I'm just going to turn it off a sec, and I'm just going to have a poke round in the power supply. Just going to check some of the main switching transistors, and there's some regulators down here. There's the other switching transistor. There. There. Okay, so all the transistors in the power supply are cold, so no worries there. Now I'm just going to check the supply rails that we've got access to. So the first one looks like it's going to be minus 21 volts. Probably helps if we're on DC volts, doesn't it? Okay, minus 21.7, close enough. Next one should be, I think that's a minus 30. Yep, and we've got that minus 30. Next one is minus 18 and it's minus 18.3. Next one is plus 30. Yep, got that. We've got a minus 20 volt supply. We've got that. Okay, this unit is doing a lot of clicking at the moment. I wonder if that's because we've got quite a low integration time set. Does that change? No. Could be we've got a noisy supply rail somewhere. We'll have to come back and check that. Okay, we've got some logic supplies down here, which I think we've got a plus 5 volt. Okay, got +5, and I can also see a +20 volt rail, and that's got 21 volts on it. Okay, now looking at the capacitors on this, certainly we're most likely to have some bad capacitors, a piece of equipment of this age. Undoubtedly we will have some bad capacitors, but just looking at it, there isn't actually that many capacitors in the power supply unit itself. There is some, what I would call the blue Phillips at the back, which are almost always bad. We've also got a large Sprague capacitor, 220 microfarad, 450 volts. Yeah, we actually have got a few electrolytics. I didn't spot them earlier. I think we've also got some wet tantalum type capacitors in here, and we've got a fair amount of ceramics. So it looks like we probably need to be doing some capacitor recapping. I'm sure that wouldn't hurt, but I don't really see any signs of excessive ripple on anything. Got a stuck main switch there. Okay. If in doubt, give it a thump. Now, because this has been stored somewhere wet, I think a lot of these connectors are in probably a bad condition. They're probably oxidized. I can see all the legs on the chips here. Some of the chips are socketed, most are soldered directly into the board. But I suspect we've got an awful lot of bad contacts. So again, what we would tend to do is we would reseat all of these chips, and in fact all of these ribbon cables. So I'm not planning on really doing a full repair today. I'm just want to assess them, because I've got 2 units and I'm trying to decide which of these units is the one to try to repair. Now this one had a label on it, sorry, and the label did say it was unserviceable. So this obviously failed the calibration test, and I think the label on it said, the label's down here, it says unserviceable AC low down. So I think, or it might say ACV down. So I'm guessing it's got a problem with its AC voltage. So I'm just looking at what the unit's doing. I'll tell you what, we will just reseat some of the obvious things while we're at it. It looks as though we've actually got quite a few layers of circuit boards here. So at the moment we're only looking at the boards on the top layer. So there could obviously be problems on the lower layers as well. All right, let's just see which of these chips we can reseat. Actually, they seem pretty firm, actually. Yeah, I am actually suspecting we've got some power supply issues here. Okay. Right, I wonder if it's going to respond to any voltage on its inputs. Now, one thing about these voltmeters, they have this quite annoying mains connector on them. Sorry, they don't have, start again, these voltmeters have these annoying connectors on the front. So unfortunately, they don't have terminals on them. I think these were made by, I think I want to call the company Fishner, something like that. Fishner connectors. I think they're about 40 or 50 pounds to actually purchase these. So I think most people who buy these voltmeters, if they manage to get them work, rather than spending 40, 50 pounds on a connector, what they tend to do is just get rid of this, and in place of it, they actually install some banana plugs. So if we do manage to get this unit in the serviceable condition, we will actually then replace this. but I'm just trying to assess it for the moment. Okay, it seems to have settled down a little bit. I suspect what's probably happened is some of the electrolytics are probably reforming slightly. They're almost certainly all bad. Okay, Andrew's just commented, was that Fisher? Filsher connectors, Switzerland. Yeah, those are the ones. Yeah, quite expensive. Sounds like a telephone exchange. Yeah, it does. So oh good, so you can actually hear it clicking. I wasn't sure whether you'd be able to hear it or not. It is settling down a bit. So yeah, I think that's probably ripple on a power supply somewhere. We could get a scope out and have a look at that if anybody's interested. Let me know, leave it in a comment. But it does seem to have settled down a bit, and it is actually reading. So we've got the integration time here, which I think is just the amount of time it does the voltage averaging when it takes a reading. So we've actually got that set at 1 second. So it should be updating the display once a second. Let's try once every 10 seconds, see if it does that correctly. Just waiting. Is it going to update? No, I'm not sure if that's updating or not. Let's go back to 1 second. Yep, maybe. Let's try 100 milliseconds. Yeah, that seems to respond in a bit faster. 20. Yeah, a bit faster still. And 1 millisecond. Yeah, so it is actually doing something. Quite like to try and put an input on it, but as I say, these are a little bit tricky to do. So let's try and just jam some wires into these. I think it's the 2 pairs of terminals that are kind of diagonal to each other. So we need a source of voltage, don't we? Let's see if we can arrange that. Oh, full wave rect. Hello. Oh, Tam Hannah, hello. Wishing you luck with the repair. Yeah, I'm going to need some luck with this one. Are there some digits missing from the display? Yes, I believe that they are. I think it only shows the full 7.5 digits when you've got the integration time set to 10 seconds. I know that Ian Scott Johnson and also the DEFPOM have got some of these meters, or they've got ones that are working, and I had a look at those videos because of course, if you're using an instrument for the first time, you're not always quite sure what it should do. Oh, okay. Andrew wants to have a look at the ripple on the scope. Yeah, I don't think we'll see that much for it being a high frequency switch mode, but we can take a look. Where was I? Yeah, so I did take a look at some other people's videos just to see what this meter should do. Now, I've got the manual behind me. Haven't read it. Of course, I should have read the manuals, but being a man, we don't read manuals unless we really, really have to, do we? So I haven't read the manual yet, but you saw how big the manual was for the K-Weeks meter. It was about 30 pages long. Well, this is the manual for the Solartron meter, which extends to, I think, about 300 pages. So no, I haven't even started reading it yet. So there is some buttons on here, and I don't actually know what they do. So let's go through them, and maybe we can just have a guess. So the first button here is local or remote. Now, I'm guessing this could either be referring to the terminals on the front or the back, or it could be referring to the mode of control, because the unit that I've got on the floor down there, that has a GPIB interface bolted to the back of it, whereas this one has, I don't know if it's well, a multi-way connector. It's bigger than a 25-way. I'm not sure how big the connector is, so I'm guessing that either means the terminals in the front or the back, or it means some form of local or remote. Now, the next two buttons that we've got here, and if anybody's got a manual in front of them, perhaps you can work out what it does. We've got two buttons here. One says, Well, it says check, so that's useful. So I wonder if that maybe looks at some kind of internal voltage reference. But we've got check, we've got a test, and we've got a step. So I don't know if that means you can actually, could you step it through some test routines? I'm not sure. I doubt you can. I don't think these are very sophisticated units. It looks as though we've mainly just got an awful lot of conventional logic on here. There maybe is, I don't know, some early processor buried somewhere, but I'm not exactly sure. So yeah, so we've got test and step. You can try pressing them, but they don't really seem to do very much. So yeah, it does seem to have an effect on the display. As Graham said, it does look as though we have some display characters which aren't lit at the moment. Got the ratio button here. Again, not exactly sure what that ratio button does. Then we've got DC volts, we've got AC volts, we've got ohms, and then moving along, we've got this integration time, which is just the averaging, which we saw earlier. And then I'm just trying to read this. And then it's got sample. So it looks as though we can do repetitive sampling, which is what we've got set at the moment because the rep button is pressed, or we can make the unit take a single reading by just pressing that, and it will do a single reading. And I've just noticed that this busy light here, when you actually do press the single button, it does appear to light up. It is coming up a little bit randomly, but if I press that, it goes to busy and then the light goes out again. So I guess that means it's busy while it's doing its averaging. I wonder if we just try that again. If we set it to 10 seconds and press busy, will this light come on for 10 seconds? Longer than 10 seconds. Okay. I wonder if there's a problem with the 10-second integration because it just stays on busy. That hasn't actually released. Go back to 1 second. Yeah, certainly seems to work for 1 second. I'm not familiar with these meters, so yeah, that's the problem. No expert looking at this for the first time, so inevitably going to get a lot of things wrong, aren't we? Shall we have a look at this display? I think we can get at this. I think we could take this front cover off. Oh, here's the man himself. Speak of the devil. I'm going to be using Ian's voltage calibrator in a second, just to see if there is any life on this input. I can see it's putting some numbers up, but I don't know whether or not they are random or not. So I can see we've got Ian with us in the chat. So Ian is the inventor of this PDVS2 Mini, and I know some of you have seen me using this before because I am starting to get a little bit more interested in calibration of equipment and just voltmeters in general. So this thing will output very, very accurate voltages right down to microvolts. And yeah, so it's much better than a power supply for testing things like digital voltmeters. I think this goes between about 0 and 10 volts. So if you want to know more about these, have a look on Ian Scott Johnson's website. Certainly they're not the type of equipment that you need every day, but when you do need something accurate, I think this is probably about the best thing on the market. It's not cheap, but it is good value for money for what it does. So check out Ian's website. What's Andrew saying there? The check group does exactly what you think. Five tests. It's 5 tests. Do you know what the tests are, Andrew? Could we step through them? 5 tests you step through. Can you find out what the steps are, Andrew? Maybe we could try those steps. Test 5, you should get all segments lit up. Oh, 11. All right, should we just try what Andrew said there? We'll go back and we'll try the test button. And he says so do we press this 5 times then? So 1, 2, 3, 4, 5. Maybe I pressed it. Test 5, you should get all ones, all 11s, all lit. I'm not sure what you're saying there, Andrew. 1, 2, 3, 4. I press it 4 times and I get that. Don't think that's all the segments, so it looks as though we've got some segments out, doesn't it? Right, so it looks like this unit has got some basic functionality, doesn't it? It is actually doing something. Let's put an input onto it. Now, it is these connectors are a little bit of a pain. So again, I was watching Ian's video earlier, and he actually did replace these connectors on his. Now, I can also just while we've got Ian with you, I can also say that when my units arrived, they were all totally smashed as well. And I think the one that DEFPOM had, I think the handles were smashed off his as well. So it does appear that the handles are a real weakness on these. But I said earlier that unfortunately the units that I've got, they are just complete trash. And unfortunately, I think in transit they were badly damaged. I don't blame the person who sold it. I just think that what happens, the things just get kicked around by Hermes, don't they? Okay, so I was just going to try and let's see what these displays look like. I'm not sure what this display technology is. It looks like some kind of cold cathode display. Can somebody leave it in the comment what these are? I'm not going to say, I generally go something like compact fluorescent, but I don't know. Some form of cold cathode display. They look a little bit more like a neon display just based on the colour. All right, you've just looked up what the equipment was. Yeah, okay. Yeah, sorry, I probably didn't explain, did I? So this is a voltage calibrator. Yeah, it provides very, very precise outputs. Need some test leads, don't we? I think everything might collapse on the bench, but let's see if we can find some test leads. I'm embarrassed to do this with Ian watching because he always shouts at me when he always laughs at my test leads, and then he shouts at me when I put this up, because apparently if you stand it this way up on the bench, it can alter the calibration of it. So he always tells me we've got to have it lie down flat. I'll try and angle the camera down a little bit. Would that help? Okay. Test for his owns should display 10R. Should we try that then? So we've still got it in test. So what's Andrew saying? Test for 1, 2, 3, 4. It seems as though these are a step out, Andrew. I don't know why. I think you were saying 5 to put all the things on, but 5 doesn't seem to do that. That comes up for step 4. So unless the test does step 1. Okay, so I'm going to press test. And now I'm going to press it once. Let's see what happens. Okay, nothing seems to happen for pressing it once. Press it again. So that's 2 presses. Don't know what that is. Press it a 3rd time. Don't know. Press it a 4th time. And it puts all the segments up. Okay. Let's go ahead and put some voltage onto this thing. Now I've got to remember from watching Ian's video what connections we have to use. I think it's this diagonal pair. I think it's cross-cornered. So I'm going to take it out of test. Let's make it read a little bit faster. I think while I've been making this video, since we've switched on, these displays have actually got brighter. So again, I'm wondering if we've got some capacitors reforming. So I'm going to switch on the calibrator. It's not going to matter whether we put this the right way up or not. Well, I hope the batteries are charged up on this. I think it just switched itself off. Oh, okay, we've got it on right. Shall we try putting? Let's try putting 20 millivolts on it. Not sure which digits are working. I think this is the decimal point here. I'll tell you what, let's try, if that is the decimal point, then maybe we can try 100 millivolt steps. So I'm going to put 100 millivolts on it. He said pressing the wrong button. No, doesn't seem to be responding to that. I thought I tested this early on just a normal power supply, and I thought I did see some action on it. Have I got the right things plugged in? I think I have. We are set to DC volts, aren't we? We've got it to local. 1 second. Oh, didn't have it. Okay, there we go. Didn't have it. I didn't. Again, not familiar with this piece of equipment. Didn't have it set right. I was on single samples rather than repetition samples, which is of course what we needed. So let's see if it bears any resemblance. So I've actually got 5.5 of a volt set at the moment, and we're displaying. Well, I think that's displaying 0.2. So that doesn't look right, does it? Does it actually respond to anything? No. Let's try 1 millivolt steps, just in case I'm looking at the wrong decimal places, which is more than likely. Hello, Simon. Just trying to see if it is actually responding to this input. I'm not sure it is. I thought it was earlier when I tried it, but I don't think it is. No. I think I have got the right inputs. Let's just check my clips are right. Well, actually, when I took the voltage source off, it did seem to change, didn't it? Let's have another go. In fact, let's try putting the clips the right way round, because again, we should be able to make it go positive or minus if it's working. So, okay, so that's coming up as 4. Disconnect them. Does it change? Yes, it has changed. Let's switch the leads round. No, I'm not sure. I can't tell actually. Again, I thought when I had some inputs on it before, it was reading positive and negative. Let's put some more voltage on it. Let's put 1 volt on it. Well, that's jumped up. Is that indicating 0.8 of a volt now? Could just be very badly out of calibration. What happens if we take that off? Okay, it floats. Let's turn it around. Okay, well, not a lot's happening with this thing now. But these connectors are particularly annoying on the front. You have the rep button. Yeah, I've got it. I have got it in repetition. Have you got the rep button? Yeah, no, I've got it in repetition. I'll just check the button. Well, something's changed because now we're just getting zeros. Has it stopped sampling? Well, it is in repetition, but yeah, it looks as though the unit stopped sampling. Have we got the test button set wrong? No, we have got it set to local. Should we try a power on test? Maybe we've upset it with all this. I don't think it's sampling anymore. I don't think there's any point in putting a voltage input onto it because I think it stopped sampling. So it does appear that something is dying, or has in fact died. Shall we see if any of the ranges are going to do anything? So let's try AC. Well, again, must have some logic functioning, I'm guessing, because I can hear relays clicking in response to these push buttons. But the display now is stuck at zeros. But it does look as though we've got some bad sections on the display. Well, okay, I'm going to stop just randomly pressing buttons because that doesn't really get us anywhere, does it? I'm using the wrong hole. Yeah, I normally do. Any other comments there? Wonder if the multiplexer is not. Yeah, it's not multiplexing. Yeah, I'm not sure what the default would be. I mean, I think we're getting a little bit of action there because this digit is flashing. Shall we just check to see if we've lost a rail? Now, of course, there could be more. There could be many more power supply rails than I'm actually checking here because, again, I've not looked at all the circuit diagrams yet. So it could just be that I'm not even, we haven't even got a good supply. So let's try the first one, minus 21. Yeah, that's still correct. Next one should be 30, which it is. Next one should be minus 18, which it is. Next one should be plus 30, which it is. Then we should have a minus 20 over here, which we have. Then we should have a plus 20, which we have. Then we should have a plus 5, which we have. So I think we have got all the supply rails. I'm just going to check the supply to this main board because the actual 18, there's an 18 volt and I think a 180 volt supply to this display board on the front. Now we've clearly got the 180 volt power supply, or these displays wouldn't be lit up because, as I say, these aren't LED displays. They are some form of high voltage type display. Let's just knock it off and let's just see if we can get at that. Oh, I just noticed it comes with an instruction sheet. Maybe we should have read that. That probably would have helped, wouldn't it? Although it wouldn't have helped me much because I think it's in French. Is the other version in English? Yep. Okay. Power supply. Okay. Not very interesting. We'll read that later. Oh, hello, dog. Right, okay, I think we're going to take the bottom panel off. So what we're going to do is we're going to have a quick look at this one, and then we'll take a look at the second unit, see if that does any better or any worse, and then we'll probably call it a day, and I'll have to do some head scratching and decide which of these I'm going to repair. I'll decide which one we're going to attempt to repair, or to be honest, if it looks like too much work, I think they're both going in the skip because yeah, life's too short, isn't it? Okay, let's see if we can get this bottom panel off now. Oops, something fell out there. Just bring you in on some of the goodness. Not really that much to see, is there? Obviously, the actual underside of the unit is far cleaner than the top side was, because dust tends not to fall upwards. Right, okay, I think we need to just unscrew. I think we've got a cover here. Oh dear, it all went horribly wrong. There we go. Can you see? Sorry about that, boys. Hello, Colin. I see you come in the room. I'm sure Colin's probably fallen asleep by now. I think he normally does. That was kind of gummed in there with something nasty. Is the cameraman drunk? He normally is, Ian, let's face it. Oh, probably shouldn't have fallen off. Oh well. Okay, so we've pulled off the front. So now, of course, I've got absolutely no idea what any of the push buttons do. So we'll move that to one side. Maybe you can. Does that give you a better look at the front of it? Maybe I can. Will the camera focus? There we go. Does that help? I'm afraid we haven't got any of those flash multiple cameras here, so that's what we're looking at. So the reason I've removed this cover is, one, I wanted to check that we didn't get any push buttons, because I just had a thought that maybe some of these push buttons were operating really stiffly, and I just wondered if this front bezel was actually trapping one of the buttons and maybe stopping it going into the range correctly. So I've just taken that off. But also we do have some, I was going to say, we've also got some horrible rust and corrosion down here. Yeah, it's really not good. I can also see, though, we've got a minus 18 volt supply rail and a plus 180. And I think we will just check them. We're going to have the 180 because if we didn't, the display wouldn't be lighting. But let's go ahead and check that. Can you see? Yeah, I think you can. Now, interestingly enough, or maybe it's not that interesting, this meter has various different ground systems on it, as most sensitive measured equipment has. So all of those voltage which I just checked there, they're off what they call the floating power supply. So all those voltages we've looked at so far, they're not referenced to the chassis, they're not referenced to Earth, they're all floating. Whereas these two supplies on the front here are referenced to Earth. So we can't use the same Earth test point. I think we're going to use this test point over here to actually measure these, because they're on a totally different power supply. Just plug in. It's funny, when this unit just comes on, the displays don't seem to work at all, and then something is maybe reforming or warming up, and then it seems to come to life. Now, I'm pretty sure it has got its voltage though, because I can see the decimal points are lighting up, so it looks as though maybe it's one of the logic rails which isn't correct somewhere. Okay, so let's just looking for minus 18 volts. Can we get on that? Yeah, minus 17, close enough. And the next rail is 180 and 175. Again, I think that's going to be close enough. Just let's try switching it off. Does that 180 rail come up instantly? Okay, that's minus 17, but yeah, that came up instantly, didn't it? Let's try the 180 rail, which I think it will. I think it is coming up, it's just hard for me to make a contact. Yeah, it is coming up. Okay, but the unit has definitely gone down. It was actually doing more than this when we first switched it on, so something has failed or something's died on this unit. Unfortunately, these are what happens. There isn't really a good way to power these up. At some point, you've just got to put power on and see what happens. Sometimes things work, sometimes they don't, sometimes something smokes. Well, we haven't seen any signs of smoke. Let's just try these buttons again, just to make sure one of them wasn't being retained. Just have that for reference. So yeah, we are set to local test. Let's try the test button again. 2, 3, 4. Okay, so we must still have some logic going because it is going into its test routine. One, 2, 3, 4. But we can clearly see we've got 1, 2, 3, 4, 5, and I think 6 digits out. So yeah. Let's take it out a test. I'm going to try putting a signal into it again, but I don't want to use the voltage calibrator, just in case I end up poking something I shouldn't, because I don't want to damage the calibrator. So I'm just going to use a power supply. So we've got the power supply set to quite high voltage, actually, plus 19 volts. So let's just see if a higher voltage does anything. Have I actually even got it set to volts? Yeah, I don't think it's measuring now. So something has gone wrong. Okay, something's gone wrong. Just before we take this off the bench, did you want to look at the power supplies for Ripple? We can get a little scope up, laugh out loud DMM with, not sure what that is, Ian. That was quick. Pocket DMMs have come a long way. Yeah, even if we get this going, I don't think it's going to be a lot of use. The reason that I purchased these is, well, it's for the usual reason. One, I was drunk, and two, they were just disgracefully cheap. It was the kind of money that it just didn't matter. If they don't work, they can go in a skip. Let's get the scope out. Or can we just balance this precariously somewhere? I'm sure we can. We're going to need a scope lead. Bear with me. Can you still see that there? Maybe I'll move everything back. I'm afraid these old Tektronix, these TDS 2022s are showing their age now. They are, I'm afraid, just dog slow. Now I'm wondering if this equipment's going to get upset if we actually earth reference a floating power supply. What does anybody think? Is it going to get upset if we actually connect it to the scope? I think the fact it's floating shouldn't cause a problem. Of course, you wouldn't want it connected if you were trying to perform true measurements, but I don't think it's going to cause any damage. But famous last words. Quite often what I might do is connect the ground clip via a resistor, and then in that case you're not actually grounding something out. I'm just going to try it. Let's see if anything goes bang. No, nothing went bang. Afraid I cannot see that. I'm going to have to turn this round. What have we actually got? Been years since I've used this thing. Sorry boys, I'm going to have to turn it around because I can't see the display. Right, there we go. So we are on channel 1. How many voltage per divisions have we got? 2 volts per division. Where do you do the coupling on this? Okay, we're AC coupled. That should be okay for looking for ripple. This is embarrassing, isn't it, when you can't work a scope? Is this set to auto or normal? It's set to auto. Where's the bleach trace gone? Don't know what I did there. Obviously something stupid. So we're on 200 millivolts per division now. Okay, I think maybe that's some switching noise. But yeah, nothing really there. Float the scope. Yeah, we could float the scope. Life's too short though. You need to do the, what's that? You need to do the diags. Well, not on a stream. Yeah, to be honest, I just wanted to see if we could even stream because this is a new. Last time I tried to do a live stream, we couldn't do anything because the internet and the computer I was using was just really slow. So now I'm using a faster computer, not particularly a good one, but it's an i7 and it's got 16 gigabytes of RAM in it, whereas the old one only had 8. And I'm using a solid state drive, and I think it's got a slightly better graphics card in it. So I don't know if that makes any difference or not. And I'm also using one of those Creative Labs stream cameras. So in theory, so I wanted to just test this setup again to see if it would work. And if we can get it to work, I might invest in some of these multiple cameras so that you can, we can get close up and actually look at what we're doing. So really, this stream today wasn't necessarily for fixing this DVM. It was for just testing the computer setup, if that makes sense. But you're all watching, so it must be working. Okay, we still got something on there. Yeah, so that was a minus 21 volt rail. Let's look at the 30. Okay, that's clean as a whistle. Let's look at the minus 18. Again, clean as a whistle. Plus 30. Again, I'm not really seeing anything there. And minus 20. That's super clean. Let's have a look at the plus 5 volt rail. A little bit of noise on there, but we're really talking pretty much nothing. How much? So just a little bit of noise on the 5 volt rail, but I wouldn't class that as being particularly problematic. So we've got 100 millivolts, just over 100 millivolts sat on top of the 5 volts, 100 millivolts of ripple sat on top of the 5 volt rail. I wouldn't consider that would cause a problem. I don't think that would stop it from working. Spiky noise, yeah, it is spiky, but I still don't believe that I'd actually stop it from working. I wonder what Ian thinks, because he's got one of these. If Ian's still with us, perhaps he can leave a comment. So let's check what the other supply was. We've also got a plus 21 volt supply. Well, that one looks a bit noisier, doesn't it? In fact, it looks a lot noisier. What's that got on it? Actually, that's got a few hundred millivolts of ripple. So that one does look a little bit noisy. So what's that one? So that one's got well, pretty much 500 millivolts of ripple on it, that one. So maybe we need to check what this plus 21 volt rail is. This is test point 31 plus 21 volt. In fact, what we'll do is we'll take my writing pad and we'll make a note of that, and I will check that off camera to find out exactly what it is. Because 500 millivolt is a little bit high, I would have thought, but then again, it is on a rail that's 21 volts, so as a ratio of the actual rail, it's not that high. So make a note of that. TP21, TP31. I think there is actually some diagrams in the power supply section that actually show some of the waveforms. So again, when I've got more time off camera, when I'm not live streaming, I will I'll take a look at those diagrams and see if it is in standard or not. What's Simon saying? Saying 405? I'm in 625. Yeah, 60. Simon's in 405. Okay. Right. Okay. Just making sure I'm not neglecting any of you in the chat. No, you're all there. So with the exception of this 21 volt rail, which has got 500 millivolts of ripple on it, all the rails look pretty good to me. I don't think that there's a problem with them. Of course, changing out capacitors may help, but they don't look that bad to me. So I'm going to disconnect this unit for now, and let's look at the second unit. '21 is unregulated. 20 is likely unregulated. Yeah, I don't know. I think the power supply section, I don't know if it's actually published in the manual. I did download it separately, but I haven't looked at it yet. Let me just see if I have printed that off. No, it doesn't look like. I'm afraid I haven't got a print off of the power supply section at the moment. What I will do is I will find it, and if anybody's interested, I will put it in the Dropbox along with the manual and the other information. What I've started doing for any of my videos, because I want you to all play along at home, and of course somebody else might be trying to repair one of these in the future and want some information. What I've started doing is if I collect together some information, I'm putting a Dropbox and then a link in the show notes. So anybody in the future who wants to know a little bit more about these or needs some reference pictures, maybe they've got one and they've got wires disconnected, I'm taking pictures of them, I'm putting them in a Dropbox, and then anybody can download the manuals or the pictures or anything like that. And I guess I'll keep doing that until somebody barfs about copyright, at which point we'll have to take them down. But that's certainly the plan anyway. So I need to read this offline and have another look, try and figure out how this thing works. Let's get the other unit out. These units are surprisingly heavy. Oh, yeah, that really weighs a ton. In fact, this one is even heavier because you see this big box at the back. I think this is some form of serial to some, well, I think it would have been a serial interface on the original ones. But I think what that does, this big box, the other unit doesn't have this big box on it, so I'll just turn it round. I think what this is, I think it says on somewhere, this is a GPIB interface. Now, I guess a lot of you guys are vintage radio people, so you might not have come across GPIB. So GPIB, it became kind of an international standard. I think, I could be wrong, but I think it was probably somebody like HP that invented GPIB, but I'm not exactly sure. But basically, if you want one piece of test equipment to talk to another piece of test equipment, or maybe you want to automate it, maybe you've got a signal generator and you want to be able to change what it outputs, what you can do is if you've got a GPIB interface, you can actually send commands via a computer or something like that. So for example, you could tell your what's that? Oh, I've just finished what I'm saying, and then we'll look at Ian's comment. So what you could do with GPIB, you could connect all your test equipment together using these serial cables, and you would actually daisy chain them like Christmas tree lights. One piece of equipment will connect to another, and then maybe at the end of that chain of test equipment, you'd have a computer. And what the computer could do then, it could actually send instructions to all your various bits of test gear to make it output things. But more importantly, you could actually get the measurements back from the voltmeter, for example, into the computer. So quite often you might have things like a power supply and a signal generator, and what you would, and a voltmeter, for example, and you could input a certain level of signal into your device under test, and then you could use the voltmeter to actually measure what the output voltage was, various test points on your piece of equipment, and then you could use the computer to decide if those measurements were good or not. So GPIB, to put it simply, it was just a way of automating test gear. I think it's pretty much been replaced now. I think a lot of the modern test gear has Ethernet on it. I know some people have also got USB, but I think more or less everything's going to Ethernet these days. I think Ian's saying only the plus and minus 18 volt rails are fully regulated. Yeah, I think that might be right. It was more the ripple that I was looking at on the I think it was a minus 21, so it could be a dodgy capacitor on that rail. What I'll do is I'll investigate that off camera just to see if it's noisy. I think all those voltages there that Ian's just listed, the plus 30, plus 21. If you look at the circuit diagram for the power supply, you've got I'm going to call it a high frequency. You've got a ferrite based transformer, a switching transformer, and they take multiple tap-ins off that transformer, and then they effectively just regulate them, or they regulate some of them. Usually the way these work is they'll actually monitor the output from one of the rails. They test one of the output voltages via a feedback circuit, and if that voltage is correct, they assume that all the other voltage will be, or it seems to work. So I think that's probably what they're doing here. Okay, HPIB. Oh yeah, HP, old bloke. If yeah, they did invent an awful lot of stuff, didn't they, HP? So this is the second unit with. Oh, okay. Really swore then. One of the knobs has just broken off. Yeah, as I say, these were really badly handled in transit. The handles and the fronts were smashed on them. So this one, I've already taken the front off this one because it was smashed. So let me just turn it round. Now, the actual physical condition of this one, I think this is I think this is a newer unit. Let me just have a look. I'm just looking for some date codes on the chips. Let me turn it around. Okay, I think this is a lot later. I've just spotted a chip there which I think's got an 84 date code, 82, 84. Now, if you're wondering why I'm struggling to read this, I said that one of the units looked as though it had a cup of coffee or something tipped into it. So this is the unit, and some of you might have seen my post on Twitter's where I had a glass of wine balanced on top of here, and God, you should see some of the whinging people on Facebook whinging on about oh, you shouldn't mix alcohol with electricity in test gear, and God, some of the little babies are throwing the teddies out the prams. It's quite funny, really. Amazing how you can annoy people so easily. Anyway, what I was trying to say is, I don't know if it'll show up on camera. Can I put some light on it? This one is thick with something really sticky and disgusting. I think something has been poured into this and it's congealed and gone horrible. So yeah, I mean, it's probably questionable whether or not we should power it on. So we are going to power it on and see what happens. But what I was saying was this unit looks an awful lot more modern. So yeah, we're getting date codes here for up to 1984. In fact, the majority of the chips on this second logic board are 84. So yeah, so this unit here is actually about 10 years younger than the first unit we looked at. Just looking for any signs of bulging capacitors or anything else leaking before we switch it on. Oh, I did have a question. I bet Simon will know the answer to this. I noticed that there is some of these silver. Oh, everything's being whited out, isn't it? Is that going to focus? Focus you. We've got some kind of little cylindrical axial capacitors here, and I think this one, for example, says STC on it. I think it then says TAA. Are those wet tantalum capacitors? I think that's a wet tantalum, but I'm not sure. I think it is. Yeah, so does anybody know the answer to that? I'd just be interested to find out. So yeah, so this is a much more modern unit, but in theory, I think it's the same as the first. Just looking for any differences. Can't see any differences. This one seems to have a header in place. Did the other one have that header on it? Let me double check. Yeah, it did have. I think what I might try to do before I put power on, I'm just going to do what I did before and try to reseat some of these plugs because I can see that they're in a mess. No, not necessarily. I thought they were. Oh, tantalum. What are you saying there, Simon? Are they tantalum? Yeah, Doug's saying they stayed in production for 20 years. Yeah, certainly there is a big age difference. I don't know if I said it, I'm just going around the unit. I can see that some of these ribbon cable connectors, some of them are partially undone. So I'm just pulling them out and plugging them back down again. I said earlier, but for those of you who've joined us a bit later, these units were bought as being known unserviceable. Somebody tried to fix them in the past and they'd given up, they'd failed. So when these arrived to me, various connectors and other things were unplugged. So I'm just going around and I'm plugging everything back in. So I'm not surprised that neither of these units are working properly, and I actually didn't expect that they would work. Okay, well, I've reseated everything that I can obviously see. So what we'll do is we'll do the same before. We'll put some power on it and we will check power supplies. Well, that one's a little bit more exciting, isn't it? If I'm really quiet, can you hear the relays are clicking? It's actually, there's some, these are read relays that I can hear clicking at the moment. Can you hear that? No, it's just stopped. It's bound to, wasn't it? There we go. Did you hear that? Click, click. So looks like we've got some action on the logic board anyway, because something is clicking, but we've got, oh, well, just various confusion on the front panel. Now, I'm wondering if we're getting that various levels of confusion here, because this logic board here, and this logic board says main counter memory board. So that makes me think it could be something to do with averaging the display values or something like that. Could be something to do with driving the display. Of course, if this one is just contaminated with muck and goo, as it is, that could cause this thing to wreak havoc, couldn't it? But one thing that we are seeing is at least all the displays are lit up on this one. So yeah, so we clearly do have some duff displays on the other one. Right, okay. I'm going to check power supplies the same as we did before. And then I'm going to switch off and I'm going to run my finger around the output transistors in the power supply and just see if we've got anything getting too warm. So the first one I think should be minus 21 volts, which we've got, minus 21. Next one is minus 30, minus 29, which we've got. Next one, minus 18, minus 17.7, close enough. Minus 30, minus 29.6, damn close. Next one is minus 20 volts, which we've got. And we've got a plus 20 volt rail, which we've got. Next one is plus 5. So our plus 5 rail is just a little bit down, 4.8. I mean, I would still class that as being within spec, but it is a little bit lower. I think the other one was bang on 5. It could be that we're drawing a little bit of current on the 5 volt rail, something being pulled down. It's possible, isn't it? And the next one is a 21 volt rail. It's bang on 21. So yeah, no complaints there. Can we just get on to these other rails here? So this is a minus 18 volt rail. Oh, I'm on the wrong. Okay, remember I mentioned the two ground systems. We've got a floating ground and an earth ground. So we need to be on the earth ground. Let's go on here. Is that the minus 18? Oh, actually, that's a little bit low or a little bit high at minus 16. That should be minus 18. Let's try the 180. The 180 is going to be fine because these things are lit up. Okay, it's fluctuating, but it's fluctuating, I'm guessing, as a response to these displays pulling current when they're being turned on. So, that's interesting, isn't it? I don't think the voltage dropping out, it could be that the voltage dropping out is causing these displays to stop striking. That's one possibility, because they do need a maintaining voltage. Could it be that the voltage is dropping out? It's certainly jumping up and down. I've still got a feeling it isn't that. No, I think they're probably okay. Right, I wonder if we can try some of those other tests that we did before. Now, this one obviously has clearly got problems again because we're just getting nonsense on the display. Let's see what we've got it set to. So we've got it set to local, yeah, which is correct. Let's put the test button in. And let's try Andrew's test. I think he said press it 5 times, but the other one seemed to do it 4 times. 1, 2, 3, 4. Did that make any difference? One, 2, 3, 4, 5. No. Yeah, so the this seems to be doing less than the other one. Maybe the logic isn't functioning here. What was the next button? Next one was ratio. I don't think we had that button pressed in. Let's try DC volts. No, that's no good. So that one's DC volts, AC volts, ohms. Has no effect. Let's try this integration time. So we are set to that single, going to repetition sampling. Okay, so that's 10-second sampling. Okay, so we're just getting random flashing on here. So this one isn't doing much at all. I wonder if the logic is running. At this stage, I've got no idea. Now, interestingly, this display, though, does actually seem to have more on it. All the digits are functioning. Do you think it's worth us changing out this display? Just the last thing we do today. Shall we try swapping this display into a different unit, or shall we call it a day? What does anybody think? Leave it in the comments. The 5 volts on the scope, we can go back and have another look at that if you want to see the 5 volts. I think I did check the 5 volt rail. I think it was okay, but maybe did I miss it? Yeah, the 180 looks fine. It's just being loaded. Yeah, I think it's just being loaded as well. Yes, swap the display. Keep going. 5 volts is a little bit low. It is a little bit low. Okay, let's. Simon wants to try swapping out that display board. I don't think this should be bad to get out, actually. I think it comes out as one big unit. I'm going to need the soldering iron on. So, I don't know, what do any of you think so far? Rubbish? No, I mean, which unit looks the best? I mean, I'm seriously thinking, should we even bother with these? Because I just think they're going to be an awful lot of work and no guarantee that either of them will work at the end of it. So have you got a favourite between the first unit we saw and the one with the GPIB interface? Do you have any preference for which one's more like to work? I actually thought the first one was showing more signs of life, but of course this one could just be a dead simple fault, because there is another circuit board under here. We haven't checked. We've only checked the rails on these top boards. We don't know what's going on under here, so it really could be anything. It could just be a simple fault stopping this from working, but I don't see there's much difference in these two. They seem pretty both of them seem pretty crap, don't they? One on the benches for parts. Okay, yeah. Well, this one, like I say, a lot of the buttons and the switches are smashed off this one, but it's a newer unit, Simon. This one is 10 years younger than the previous one. So, have I unplugged? Yeah. Let's just make sure the capacitors are discharged. Yeah, they are, so that's fine. How do you get this out? Okay, it's fairly easy to come out of that. Right, got a couple of leads on the front here, and it would really ruin my day if I get these mixed up, because one of them's got 180 volts on, the one should be minus 18. So let's just make some notes of this. (180) is on the right, and minus 18 is on the left, and 180 volts has got an orange wire, And what's the -18? Purple wire. Okay, make some notes, don't want to blow anything up. Okay, my soldering iron hasn't come on. Oh, maybe I didn't switch it on after all. Well, I'm quite surprised that you're all staying and watching, so thanks everybody for the support today, for joining me. I suppose this is slightly better than Murder, She Wrote, but yeah, I don't know, maybe I'd have watched Murder, She Wrote, that might have been more entertaining. Of course, when you are trying to diagnose faults and things, having a spare unit is really invaluable, because you can do things like this. You can maybe just swap parts around to try and get one working. Or the other way around, maybe, yeah. I'm just here for the giveaways. You'll be here a long time, Brett. Remember, I'm a Yorkshireman. You don't get much tighter than me. I'm actually going to use the birthday present that one of you guys sent me. So somebody very kindly for my birthday a few weeks ago sent me some Nipex pliers. So I'm going to give them a bit of an outing. This is one of them jobs, I'm afraid, where filming makes it that much easier, not much more difficult. Because now I think that these connectors were originally some form of like crimp-on connector, but clearly somebody went over them with a soldering iron, maybe because they were loose. In fact, all that is doing is it's melting the pin and pulling the whole pin out. So I'm not even going to try and undo the crimp. I'm not going to tolerate that. I'll have one last go. I don't want to pull the pin out of the circuit board. No, can't do that. What we're going to do is going to cut the crimp off. I'm sure some of you are all spinning and getting angry that I'm cutting it off. It's better to cut something off than it is to damage the circuit board, so I'm choosing to cut it off. There's quite a lot of what I would call, these wires would have been held onto these pegs on the boards by a little round crimp, but I can see that the crimps, they must have had problems with these little crimp connectors coming loose, because pretty much everywhere, I can actually see a couple of connectors that haven't, but most of these little crimps, which should have just pushed on, they've actually been soldered on, so they've had problems with them. Whether that was a production problem or a service modification, I don't know. So that came out fairly easily. So can you see that? This is where we say focus. This is a video about the dark forces. Oh, here's Rob. Hello, Rob. Nice to see you. The displays are gas plasma, same type used in the pinball machines. Actually, now you've said that, Rob, it brings back memories. You're right, aren't you? Of course, Rob is dead right. So that's a close look at the display, and it is reminiscent of the ones used in those pinball machines, isn't it? Now, this display plugs in on these edge connectors here, and these are, I suspect, are going to be fiendishly difficult to try to line up when we push it back, because each one of these connectors, it's not joined or fixed down to the board, you know, like a normal header connector. It's not in a plastic molding, so they all just flop around and move. So this is the display that appeared to have all the segments working, and I would have thought that I could probably call out some numbers. Unfortunately, I can't quite see what the numbers on these ICs are, but we've got a number of ICs that are in sockets here, and I would take a guess that they are the high voltage switching ICs for actually controlling the segments. So it could be that on the other unit we either had some duff displays or we had some duff high voltage switching units that were maybe stopping these coming on. So I think we stand a good chance by just swapping the whole display unit out of getting it working. We seen enough of that? Okay, just put that over there a minute. It looks as though you can actually get some switch cleaner in the back of these switches. Again, it might not be a good idea to spray switch cleaner into some of these switches because this is a precision voltmeter, but yeah, it looks as though they've got a hole in the back. In fact, I can feel the plunger come through. So yeah, I can get some switch cleaner through the backs of these if we need to. Because it is always worth cleaning the switches. As I say, this one's had something like a cup of tea tipped inside it. So everything is really gummy. And I definitely think it's worth me taking this board out and washing it with IPA and putting it back in, because it could just be that whatever residue is on here is shorting out this memory logic and maybe causing it to be corrupt. That's quite likely. So we will try and take this board out, and if we do repair these, that's probably the first thing we'll do. We'll take some of these boards out and we'll give them a wash, because we've got to remove all of this contamination. Okay, so that's the unit with the GPIB, made in 1984. Oh god, that is a weight. So this is the older unit, and I think we said this has got a date code on of again, some of these chips are so dirty. Let me give them a wipe. I think I said 74, didn't I? Come on, must be a date code somewhere. Oh, actually, I think I misread the date code. I said 74. That's rubbish. That's a bit of a newbie error. Okay, so I misread the date code. These again, these are just filthy, these ICs. So the date code is 82. So they're not so far apart, are they? In fact, is that the same age? I've forgotten already. But certainly they're not. This one isn't 70s, it's 80s. Yeah, sorry about that. I think I must have been reading the actual 7-4 logic number, but it's hard to tell. These things are filthy. Okay, so we need to take this off. Brett's popping to the shop. Are we going to let him? Somebody block the door. Nobody's allowed to leave alive. If you're getting biscuit, Brett, you know, we all expect one. So I'm just taking off. We've got some of these little brass fingers which are actually sitting on top of various places on the enclosure. So these are actually the grounding strips. I don't think these are placed there for electrical safety. Of course, they do that as well. But the main purpose of these, if you get any high precision measuring equipment, especially RF equipment, this is not RF, but just precision equipment, you tend to get a lot of these little copper fingers. And the idea is that these fingers, they press against the inside of the cover, because you need to make sure that these covers are correctly grounded so they don't actually become big radiating antennas and pick up noise, which could affect the reading. So you quite often see any precision test gear will have lots of these little copper fingers at various places. Looks like this has been assembled with some thread locker on it. Yep, some white thread lock. Yeah, you thought the display would have been LED, but I think these were originally made. They were originally made, I think, around 1971, 72. So I think it was you that said, Doug, that this equipment actually had quite a long life. So maybe it was one of them things that rather than redesigning it and maybe having to do EMC testing and all that lot, they just decided to just carry on with the display technology rather than to put LEDs in it. So in theory, this should just lift up now. There we go. Okay, and this one is actually crimped on. I'm afraid I can't bring you in, but I can just unplug these, I think. So the others were soldered on, whereas these were just plugged in. So that's the DUF display, or we think it could be DUF, although it could still be the logic. Pen. Anybody see where I put the pen? I'll find one. I'm just going to write bad on here, because we think it was bad. Certainly it had some sections that weren't working. But it does look the same as the other one. I can see some warning labels, danger, high voltage. Again, same connectors. So that's the bad one. I'm just umming and ahhing a little bit because ideally I'd like to get that old crimp off. I don't think I'm going to be able to do it because it's kind of a free-handed job in that I'd have to try to... I'm trying to hold the peg in but pull the crimp off. No, that's not going to do. That's not going to work. I'm just going to solder these on. That's how they came off. Do need to get them the right way around. So -18 was on the left and was purple. Yeah, it's bothering me, that though. I wonder if we try and use some solder braid on them, if we can pull enough solder off to get the crimp off. I don't think this is going to work, but it's worth a try. What I'm fighting with, for those that have just joined me, there's some crimp terminals on here, and they've been soldered on. They should be crimps, but they've actually been soldered on, and I'm struggling to get them off. Ideally, what I need is a third hand. I need to hold the pin in position, heat up the crimp, and then I need another pair of pliers to actually pull the old crimp off. And I think that's where I'm struggling. Okay, got it. No, struggling with that one. Let's try removing some solder. If you're new in the comments, you'll need a drink. I need a drink. Yeah, I do need a drink. What time is it there? The time is 15:54 according to my clock. Is that correct? No, I'm going to stop tugging at that one because I don't want to break it off. Which is what's going to happen. Right, we can get one of them on. So what did we say? Minus 18 volts is purple, so we'll put that one on. Tell you what, I don't like giving up. Didn't help the fact I was trying to fight with the camera and keep everything in shot. So for the purpose of trying to do this, I'm gonna have another go, kind of off camera. Get the wine out, Chris. You know, on Facebook, the amount of people that complained about the picture of me drinking wine with it stuck on top of this old piece of crappy test gear, it was amazing, really. Just wondering, can I snip at the side of this crimp? Will it kind of halfway cut through it? Hey, success! Got it off. Hey. So clearly they must have had a production problem with these and decided that they were going to solder the crimps on rather than just, you know, relying on the crimp itself. So what we're going to do is, I think I do need a drink, and I think I've kept you guys long enough. What we're going to do is we're going to try and install this unit, and we will try and install this display, and then when we've done that, we're going to call it a day. I've forgotten which unit's which now. Oh dear. You can see Ultimate Professional. Okay, so that's got the good crimps on it. So yeah, that was the one, wasn't it? So we said minus 18 volts is the purple, and 180 volts was the orange. There's only two of them, so we can't really get that wrong, he said. And now the trouble is trying to line all these pins up with these header connectors. That is no easy task. I think that's going. think we've got it. Oh, where the hell did that come from? Maybe it was down there. Right, so in theory, we've got a good display into the other unit now. Is it going to work? Is it going to explode? I don't know. Just before I plug it in, anybody get anything to say? At least it's 1984, yeah, okay. It's daylight. Time is irrelevant. Well, yeah, but I guess there might be a few people listening from across the pond or watching. Do you have all the Solartron 707 files? I don't know what I've got and what I haven't got, Ian. I've certainly got what I'm classing as the service and calibration manual, and I've got the I've got some information that's in the manual. It's fun to fill a Friday afternoon. That's very kind of you to say, Paul. I think I'm going to have to bring these things to a stop, though, to be honest, guys, because, you know, in honesty, I'm running out of my level of education that I have on these units. We're at the stage now where I think I've got to stop and I've got to read the manuals and try and learn a little bit more about how these units actually function, because I don't know, and I'm not just going to try and blag my way through and pretend I know when I don't. So we'll just try this display. We'll see if it does anything different, and I think that'll be a logical place to stop. I'm just going to double check then connections. Purple was -18, yeah. Okay, let's plug in and see if anything happens. Well, I think we've got more digits working, but it's not quite. How many digits have we got there? So we've got 1, 2, 3, 4, 5, 6, 7, 8. Is that all the digits? Let's try that test thing again. So 1, 2, 3, 4. Oh, bingo. So that looks like more of a win, doesn't it? More zeros up now. Yeah. Yeah, so I reckon that's up, isn't it, boys? But I don't think it's functioning now, and it's not measuring. So got to make sure I've got the switches. I'm just going to do one quick input test, make sure I've got the switches set right. So we need it set to local, which we have. We don't want it in test mode, so it's not in test mode. I don't think we have ratio selected. I'm not sure what ratio does. I bet Ian knows. What does ratio do, Ian? I don't think we want ratio set. We will put DC on it, DC set. And we've got 1 millisecond, 20 milliseconds, 100 millisecond. Let's try, I think 1 second integration is best, because in theory you can see it flickering. Oh, I've got some relays clicking. Okay, got some relays making a clicking sound. Okay, so we've got 1 second integration time. Got single or repetition. We do want it on repetition. Almost sounds like something's arcing down there, but I think it's a relay. Ratio is null. What does that mean, Simon? Well, ratio is null. Well, that's for nulling something out, is it? I don't know. Yeah, all zeros. That can't be right. That can't be good. I would expect this input to be floating around a little bit if it was working. So let's try and put some volts on them again. We're not expecting anything. Got about 1.5 volts on the power supply. And I think it was cross-cornered you had to go. Now when I actually put these terminals in here, there's something clicking, the unit clicks, so I think it's doing some kind of ranging. But we're not getting any display on the front here, and we were before. So yeah, I think that's as far as we can take it, because I need to study this a little bit more to find out how the logic works. I don't know if there's a processor on this board somewhere. Is that running? I've got no idea. So I think it gets to this point now where we've really got to consult the manual and start maybe even going through things like the calibration procedure, because the calibration procedure will at least tell you what voltage and what measurements you should have in certain places. So I think that's where we are. I haven't got anything unplugged, have I? Okay, well, it stopped clicking and buzzing now. I don't know if that's a good sign or not. No, I think, boys, that's probably it for today. So we've got a working display now. Did some of you want to check that last 5 volt plus 5 volts? Because you said we didn't check it, didn't you? I think I did check it, but maybe I didn't. So what I'm going to start doing is, once I've finished for today, I'm going to start reading the manual for this and try and get an idea of how this thing actually works. And it's quite likely, of course, you will never see this unit again, because, you know, like doctors, we just bury our failures, don't we? And I don't think it's very entertaining just watching somebody fail to repair a voltmeter. So what we'll do is, if we see any signs of life, we'll bring you back for another episode. Otherwise, we'll just keep this amongst ourselves and we will never mention it again. Right, sorry, what we set to? The problem is, when you have in excess of 20 or 30 oscilloscopes like I do, you forget how to operate pretty much all of them. So yeah, so we're on AC coupling. Let's try a wiggle. Yeah, there's some wiggling action. Yeah, there's not a lot of noise on there, you know. Let me just zero that. What we're on, 200 millivolts per division. Let's go to 50 millivolts per division. Well, there is some high-speed switching noise on there, but again, I don't think that would stop it from working. So yeah, typical kind of switching noise that you'd kind of expect to see from a switching regulator. Yeah, I don't think that's so bad actually. There is a couple of 100 millivolts of ripple on top of the 5-volt rail, but um, I don't think that's going to stop anything from working personally. No, manual, don't know the word. I think you're lying there. You strike me in as somebody who reads manuals very carefully, because watching your videos, you'll always know what's going on. So I think you must have a sneaky peek at those manuals in the background. You're kidding me. Right, okay. I think for today, that will probably bring things to an end. I probably will be. I'll be ringing all my friends now, ringing Simon and ringing Ian, probably to get some advice on what we need to look at next. But I think that's about as much as we can do for today. Not really sure where to tackle it. I don't like just changing capacitors, because although we know the electrolytics won't be great, I just never like just going through shotgunning things. I would rather find the fault rather than just shotgunning things. Yeah, maybe a recap might things get going. Yeah, they very well might, but I prefer not to do that unless I have to. Okay, I'm just wittering now, so I think we'll call it a day. Thanks very much for watching, everybody. I think it has been interesting. Still none the wiser which one of these is the best one to try tackling, because yeah, both of them seem pretty poor. So yeah, so I'll have to think about it. Until next time, as always, thanks very much for watching. But bye bye for now. Bye everybody.